I want to see if I can solve this in a couple minutes. I'll give you the big picture. Coin change. You're given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of coins, return -1. Assume that you have an infinite number of each kind of coin. So let's say you have all these coins and you want to make up some amount, 11, right? Well, what you can do is you can consider this as a problem of subproblems and think about the dynamic programming solution to this, right? So you have some 11 target, and maybe the subproblems are all the numbers that are smaller than it, right? So if you can solve how many coins does it get to 1, then you go to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you can say to yourself, we've done a single linear operation on this end, and then maybe some time spent on what does it take to fill every one of these boxes, right? And what does it take it to fill any one of these boxes? Well, let's say you have the coins in the example, 1, 2, and 5 available to you. And let's say we're processing the first one. We're processing this 1, right? And there may be a 0 here if you want, and the 0 will, presumably always be 0. But let's say now you're processing the 1, and you can imagine that if the coin is found, then it's 1, right? Every time you actually have a coin match, it's only 1, right? So let's say a little bit harder, this 3, right? So how do you process the 3? There is no coin that matches it. There are some coins that are smaller than it, so these are valid, right? So the coins that are smaller than it are valid. Well, then we can look back and say, let's say we want to use the 1 for right now. We want to use the 1. Well, 3 minus 1, or 3 minus 1 is 2, right? So if we look at the 2, how many coins does it take to make 2? It took 1 coin, right? So 1 coin plus the 1 coin here, the 1, this is a 2, right? It takes 2 coins. Well, what about the 3? 3 minus 2 is 1. If you look back at the 1, well, this is also a 1, and then 1 plus 1 is 2. Okay, great. So that's how we populate the 3. How do we do it to the 4? Well, the 4, something similar, right? What's smaller than 4? Well, the 1 and the 2 are both smaller than 4. Now for the 1, 4 minus 1 equals 3. If you look at the 3, it took 2 coins to make 3, right? 4 minus 2 equals 2. If you look here, it only took 1 coin to make 2, right? So which one should we choose? Should we choose the 2 plus 1, or should we choose the 1 plus 1? We should choose the 1 plus 1, right? So this should be 2. Now, what does that mean for us? That means up here, we have some choices, right? And we have the values of those choices, and then we take a min of this, right? We take a min of those choices and those values, and then we do a min plus 1, and that is the value of the new position, right? So if we had options, option 1 would be the same value, right? Coin and target. So then we set that to 1. Number 2 is of the smaller coins, right? Collect the values, right? And then of these, we get the min, right? We set the min. And at the very, very, very end, we return this position, right? Go ahead and make that green. At the very end, we return this position. Okay? So that is the coin change problem in a nutshell. You can figure out how to write the code for it, but that is the core idea